So yes, Michael, you will never be submitting that for a grade. How's that?
That's fine by me.
Okay, so that's what we got.
Stop.
But that is stuff that's going to be on the second day of next week's quiz. So your quiz next week will be Wednesday and Thursday. Wednesday will be problems like the homework ones, like the general ones, like the last quiz. And then Thursday's second part of the quiz will be a lot like that. All right, so just so you know. Chapter 12, we got some answers coming up. So I believe we got to go over 12-2 today, correct?
I believe that is correct.
All right, so let's give a gander, shall we? Uh-oh.
On interruption, attention all seniors. Senior service day forms are due tomorrow in the 11-12 office or room 219 before third period. Again, attention all seniors, senior service day. Tomorrow is the last day to return those forms to either the 11-12 main office or room 219 before third period. Thank you.
Literally that applies to none of us. It's gonna be like
You're up in the 11th?
Thank God it does not apply to any of us here because we would have so much trouble getting to a 12.4.
I mean, yeah, I
Because they wouldn't have enough. I mean, granted, it's gonna be on like a recording and stuff like that, but then again. Oh, wait, never mind. It says a permission to start it. Wow. My mistake. My mistake.
All right.
God, that's on like an $8 million. Yeah, it's like $3 something. Let's check this out. Actually, Gary Sanchez is batting like 120. Oh my God. And can't catch her ball.
Oh, stop him, Gary.
All right, there you go. There's 1 through 6.
Somebody's
Good. With the first 6.
Somebody gonna say your last.
Number 3. How did you get 16? I got 8.
Because, see how they're the same distance from the center? X is the whole segment, so 8 only represents the part of it. So 8 only represents, here. 8 only represents, it's not your fault. That's why when we give you the quiz, it'll be a lot more specific. So 8 just represents that part. So this would also be what? 8. And 8 plus 8 is what? 16. So again, we would be more specific with the directions on any quiz test to make sure you understand what segment they're looking for. So in all honesty, Michael, instead of just doing it like that, more likely on the quiz, they'll be given vertices. So this will be like A, B, C, D, E, F, G. And it'll say A, B is 3, A, D is 3.
Okay,
You know what I'm saying? It'll give you the letters so you know exactly which one they're talking about.
Okay, fair enough.
Oh, thanks. All right. Okay, everybody else good? All right. So then there is 7 through 11.
I don't even have an eraser.
Give me a second, Michael, okay? See if that makes sense. So that's the right triangle it creates. Good. So in other words, the So in other words, the distance is the 8 to 15 left-handers. And then B is part of the chord. That's the 1 square root of 161. And then they get the other part of the chord. Since that's perpendicular, it's got to be the midpoint. You just got to double 161. And then you estimate, and that's what gives you the number. That's my
For number 8, I got 4 root 2. And for number 11, I got 6 root 6.
Number 8, you got 4 root 2?
Yeah.
That's about right.
Okay.
And then number 11, you said what?
6 root 6.
So like,
6 root 6?
yeah, like,
Yeah, you're good.
Okie dokie. Now that is about
Just make sure you follow the direction.
yeah, that kind of serves now. Like that, like I heard.
All right. Good.
Okie dokie.
Guys. Yeah.
Okie dokie. Now that is about
All right, so if I draw the radii on the bottom part, I got that, the 4.2 and the 5. That's got to be the midpoint. All right, so when I do Pythagorean theorem, 4.2 squared plus 5 squared, this is the square root of 42.64. All right, which gives me the 6.5. And then if you look at that segment X, that's also a radius. They'd have to be the same length. All right, with regards to the proofs, I'll gladly talk about 12 next week when we talk about the packet, but 12 involves drawing in line segments JM and JL as radii. You're not going to have one like that next week, but beginning Monday, we can go through that, but take a look at 13, 14, and 15, and 16. The proofs you have on next week's quiz will be more likely looking like the ones you got in the packet yesterday. You good with that setup? Okay. Cut it in half. You're good from there?
Oh, shoot. I can't believe you done this.
And then there's 18. What?
I got half of that
Don't care.
on number 18.
Do you want me to go over 18?
Yes, please. And, 15, 16, I thought I should have asked before. That's not my part. Alright.
Just throw like 1 through 4.
At least I'm putting the blame on myself. Right? Right, guys? At least I'm putting the blame on myself. Oh, that's what it means. Just a scratch.
Good for now.
Yeah, I'm good with that.
You would use PT to get that. Okay, so now you're looking at, but then remember you got to multiply it by 2. Because it's perpendicular, it's got to be the midpoint.
Oh, that a little bit.
All right.
But wait, why multiply it?
Because you're only going to get that length, and they said they want the length of the whole cord.
Oh, the whole entire time.
That's the half part. You good now, brother?
Yeah.
You said what, 15 too?
15 and 16.
Didn't I do 16? Did I do 14? I already did 15.
Then I must not have been paying attention.
Well, then you're out of luck. If NO is 30, that means this is 15. All right, the radius is 16, so this is 16.
Okay.
All right, I'm going to use Pythagorean theorem to get that length. The 15 is down here, by the way. 16 squared minus 15 squared. And that gives me 5.6. And then they want the length of the whole figure, PQ. So again, I got to multiply 5.6 times what? 2. And I get 11.2.
Oh my god, I forgot. I keep forgetting to multiply this stuff.
You would think if you did it over and over again, you'd stop. But apparently not. You're just going to keep on doing it, aren't you? You're going to do what you
I
want.
think it might be
Nobody
easy.
puts Wilkinson in a corner.
Imagine you just threw that in the air to log. And imagine you actually threw that thing. That would have been another stage.
I was thinking the championship. With that.
Welcome, you
Yeah, I'm just looking to get the assist. I'm looking to help you out.
I know.
Little hurt. All right, 12.4, the angle measuring sidelines. Don't forget, 12.3 homework is due tonight at midnight. 12.3 homework is due tonight at midnight. All right. And like I've mentioned before, the packet does not need to be submitted. Once we get done with 12.5 on Monday, we'll start going through that packet. All right, so you do not need to submit it. It's for your use. All right. But we will talk about a problem on there that you need to know. Okay, it is up in Google Classroom, but in the first trig problem on the second page, notice I have to get it out right now. That angle is 65 degrees.
Okay, fair enough.
All right, so the top of the page that says trig, that's 65 degrees. Sunday, at some point, I'll post the solution to that. Read through it. Okay, and then if you have questions from it beginning Monday, we'll take questions on Monday after we get done with 12.5 equation of the circle. But before 12.5, of course, there's 12.4. We've already discussed. Get it, Michael? Discuss.
Yes.
There you go, buddy. Central angles, whose vertex is found at the center of the circle, and inscribed angles, whose vertex is found on the circle. Now it's time to broaden our horizons. There are ways of finding angle measures if the vertex is not located in either of these locations. Theorem 1213. The measure of angle 1 equals 1/2 x plus y, where x and y are arc measures. This is used when the lines intersect inside the circle. Good. Got it? Theorem 1214, the measure of angle formed by two lines that intersect outside a circle is half the difference of the measure of the intercepted arc. So inside you're going to add, outside you're going to subtract.
I get it. I have the joke in that picture and the title. And they interact outside. I mean, intersect outside.
So now they're just outside.
Yep, I get it.
Okay. Now, when neither of the lines are tangent, the same theorem, but that's what it looks like. You would do x minus y divided by 2. And that gives you angle 1 located over here. Okay? You can have one tangent line and their tangency. Or they can both be tangent. It doesn't matter. It's still going to be x minus y divided by 2. All right? No matter what it looks like. If the lines intersect outside.
Yeah, kind of. Oh, okay.
Good. Moving on to segments. Theorem 1215. You don't need to write this down. It says for a given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and circle. What that means for you, for intersecting chords, A times B equals C times D. A times B equals C times D.
So I see. So A and B. And C, B.
Yes, sir.
Yes, sir.
Good. Notice A and B, are they in the same chord or different chord? And B?
They are on the same chord.
Right. So the parts of the same chord multiplied together. For a pair secants, W times X plus W equals Y times Z plus Y. The product of the exterior portion and whole segments are equal. Notice, it's not W times X anymore. It's W times X plus W. All right, equals Y times Z plus Y. It would hurt. I'm sorry. I didn't mean to threaten you with violence. I'm sorry. That was way too far.
Oh, they're trying to make with a war
I was
ball.
being a little aggressive.
Do you bite
This
my
thing will
little
cause a
thumb
little bit of
at me,
pain.
sir?
All right.
Do you bite your little thumb at me, sir?
If a tangent comes to the party, t squared equals y times y plus z. The product of the whole segment and exterior portion equals the square of the tangent before hitting the point of tangency. Just so you understand, that's what we're talking about with tape. From the point of tangency to the point of intersection.
I got my
And the tangent line goes on forever, so we're talking about this part. from the point of tangent to the point of intersection. That represents 10.
Because then again, the tangent lines just go on forever.
And you can't measure it. There you go, Michael. All right.
It won't stop. It can't stop and it won't stop.
Easy, Michael Jackson. Alert.
Can't stop, won't stop.
All right. Everybody good? All right, let's do some examples on the back. All right. All right. So, first thing you look for is do they intersect inside or outside of number one? Outside. So the angle measure, which is x, is 1/2 the two arc measures, which is 72 and 22. But because it is outside, what math do we do in between them? Subtract. 72 minus 22 is 50. Half of 50 is 25 degrees. Yes, Michael?
Now, if the intersection was inside,
Then you would add.
They would add.
Yes. So do you see the diagram for number 4?
Yeah.
Yes. If it looked like that, then they would be, all right?
Then
So
we
start
add.
coming up with some ideas on how you would do number 2. Start jotting down some ideas on how you would do number 2.
Oh boy. Oh boy. Here I go doing this again.
All right. Now, one of the reasons this problem is different is instead of the arcs, what are they giving me? The angle. So 48. So we start with that. 48 equals 1/2 A minus B. Now, I write it this way for a reason. If you want to get rid of the 1/2 right away, you can by multiplying both sides by what? 2. So 96 equals, now I start filling in the arcs. So that's the point of intersection. All right. And then that's the other arc. According to the diagram, what's the measure of this arc? 140. According to the diagram, what variable represents the other arc? Nope. X. Do you see that? All right, so you take the points of intersection and you look at those two arcs. All right, and then you either use mental math or algebraic expressions to realize x is how many degrees? 44. All right, now if we slide over to number 3, that line segment is very special because it's a what?
It's a radius.
No, the whole thing is a what? Diameter. So that means this portion is a semicircle, meaning it adds up to what? 180. This is 70. That's 30. What can I then do to get that angle there? We get 80 degrees. Good? Good with that. All right, now, like Michael said, these lines intersect inside. So instead of subtracting, what could we do to get that angle there?
We can
Add and divide by 2. 70 plus 30 is? 100. Half of 100 is? So both of these angles are 50.
50.
Why is that important? Because it forms a what with x? Supplementary linear pair. So what would I subtract 50 from? 180. And x is 130. Everybody good with that? Now we got to look at y. Okay, so here's this point, here's that point, and there's this point. So that clears the two arcs that I'm talking about. This arc is the semicircle, which is how many degrees? 180. This arc is what? Y divided, of course, by what? 2 equals what angle measure? 36.
So 36 equals
180 minus y divided by 2. How do I get rid of a division by 2? So 180 minus y equals 72. And then using mental math, y is 100 and... Yes, ma'am. How'd I get to 50? All right. So one of the theorems we wrote down is when they intersect inside, all right, it's half the sum of the two arcs. So the one arc down here is what? The one up here is 70 plus 30 is 100, half of that's 50. Good? Okay. Everybody else good? All right. Now we're coming down to segments. We start with number 4. First off, see if you have two parts of the same segment. Do we have that in this diagram? We do. 6 times 5 is what? 30. And then the other segment is made up of what two components? What number and variable? So if I multiply them together, what would I have? 10x. How do you get rid of the multiplication by 10?
divided by 10.
And 30 divided by 10 is 3.
X equals 3.
All right? Good. Now, if you go down to number 5, it is different in that they intersect where? Outside. So, out of either one, give me one of the two numbers, 8 or 9. 8 or 9. 8. That's fine. What is adjacent to the 8 inside? 10. In addition to the 8, so that would be 18. Everybody see what I do? So I take the exterior part and multiply by the sum of both parts. That's going to be equal to what? What's the exterior part in the other one? 9. And the whole thing would be what variable expression? Not 9x, 9 plus x. Or x plus 9. Now, most people, their first instinct would be what? To do what in that problem? On the right-hand side. Distribute. I'm telling you, you don't have to. Why? Because 9 goes into 18. You can distribute. You'll still get the same answer if you're more comfortable with that. What's 18 divided by 9? 2. 2 times 8. 16. What are the 9s going to do on the right-hand side? Cancel out. You got 9 plus x. How do I get rid of a plus 9? And x equals 7. All right. Now in number 6, it's the exact same problem. The difference is the 12 and 10 represent what? The whole thing. You see the difference? So I would take the outside part, which is 3, and multiply by what? Now 15, Josh. 12. See the difference?
Oh, yeah,
Because it's the whole thing. For the other segment, what's the outside portion considered? What variable? X. And then the whole thing would be 10. You see the difference in the two problems? Michael?
I'm pretty sure that does it matter which order you put it in? It just
Nope.
this case.
Is multiplication's community.
Right, makes sense.
All good?
Yep.
And then you would do 3 times 12, which is, of course, 36 divided by 10, and you get 3.6. Start formulating some ideas for number 7.
Great googly moogly. first place.
Why is my favorite part of the problem the bottom part? Both portions are what? Numbered. Does that make sense? So if I were to do the math there, 9 is the outside part. What's the whole part? 25. Good. Equals. All right. And it doesn't matter the order in which you do this. What's the outside part of the segment above it? 8 times what? X plus 8. Could you solve for X using that? Absolutely. Equals. Now, what did I jot down about Y? Y is what? Tangent. When you have that concept, that's just going to be Y squared. You want to know why? Because what's the inside part of a tangent line equal to? Times with 0. 0. So when you do Y times Y plus 0, the Y plus 0 just becomes what? If I add 0 to something, does it change? No. So Y plus 0 would just be what? Y. And Y times Y would give me? That's the reason it is. All right? 9 times 25 is 225. Equals 8x plus 64. How do I get rid of a plus 64? Subtract 64 and I got 161. How do I get rid of a multiplication by 8? All right, and since it's not a length, it's just a variable, feel free to leave it like that. Now for the second part, 225 is equal to y squared. How do I undo a square? Square root, and guess what the square root of 225 is? 15.
What about the second part?
What about the second part? I did it.
8 times x plus 8, is that not relevant to finding y squared?
Not to y squared. Here's the thing, Michael, it's not really a system. 2 reasons why. Number 1, it's equal to a constant. Number 2, I can solve one variable without the other. Does that make sense? So I don't need to know what x or y is to get the other one. That's why I set it up that way.
Okay, fair enough.
With all due respect, fair enough.
Let's go.
Okay. Top of the next column, let's crank these out. Find the value of each variable using the given chord, secant, and tangent lengths. If your answer is not a whole number, round it to the nearest 10. So it's the same idea. What type of line segment is y? Chord, secant, tangent? Tangent. So it's going to be y squared. Good? Equals the interior part on the next one is what? X times what? X plus 6. Now, even though y isn't related to that circle, is x plus 6 in both circles. So that's why I'm allowed to use this. Equals is a secant, chord, or tangent? Tangent. So what can I simply do with that? Where? So y is tangent. So y times y gives me y squared. The middle part, the interior chord is x. The whole thing would be x plus 6. And then on the right, 8 is a tangent. It's not a variable. Well, what do you know y is no matter what? 8. That makes sense to everybody. Y's got to be 8. So you get a diagram like that, these two chords have to be what? Congruent. Well, what is 8 squared? 64. So x squared plus 6x, when I distribute, is 64. Good?
And read these in quadrant. Well, not
So x squared plus 6x, what's half of 6? 3. What's 3 squared? 9. I'm completing the square rather than quadratic formula because it's not going to be factorable.
What?
Take a moment. Michael, did you do completing the square last year?
Clean the square. That would be 60.
If you did not do completing the square, Michael, so we'll go to this. X squared plus 6x minus 64 equals 0. There are no two numbers that go into 64 that subtract the 6. So then I would use quadratic formula. Negative b plus minus square root of b squared minus 4ac all over 2a.
Minus,
Quadratic formula. B is your coefficient of x. What is the coefficient of x in our problem?
minus quad over 2.
This would be negative 6 plus minus the square root of 6 squared, which is what b squared represents, 36, minus 4. A is your coefficient of x. What do we assume the coefficient of x is? 1. C is your constant. What is our constant? Negative 64. All over 2 times a, which would be 2 times 1. I would then multiply this out. Negative 6 plus minus square root 256, 292, all over 2. All right? So that's using quadratic formula. Now, all right? If I start with a negative number and subtract a negative number, am I going to end up with a negative number? If I divide a negative number by 2, am I still going to have a negative number? Yes. Is x a length of a segment? Yes. So can it be a negative number? No. So I'm going to calculate this as if it's the positive. So negative 6 plus the square root, 292, 11.08 divided by 2 makes it 5.5.
How do we get that negative on there?
Quadratic formula, brother.
I need
All right.
to put it down there.
What do you mean the negative? You mean this part?
Yeah,
That's quadratic formula, pal.
on the calculator.
Oh, how do you put a negative in?
Yeah. Oh, okay.
Yeah, man.
Negative 6, and then what was the
Yep.
rest of it? Plus minus. Or what would you say was plus?
All right, guys, don't forget to do your 12.3 homework tonight. Tomorrow we'll finish this up. Have yourself a great day. I'll be in virtual math lab today. If you're looking for extra.
Got 2.54. I did not do something right.